I hear the word transit time ultrasound, a whole range of technology capabilities comes to mind. You can do ultrasound indicator dilution, the most accurate method on the planet to do indicator dilution. You can do bubble detect, you can measure liquid properties. The possibilities are endless.
Transit time ultrasound is the time of flight of an ultrasound signal between two transducers. With Transonic, we measure in an upstream and then downstream fashion and then take the difference of those signals to give us a volume flow measurement.
So in theory, transit time ultrasound technology is fairly straightforward, but there are highly complex processes involved in producing the components. The operators are highly skilled and do a lot of hands-on microscopic soldering and fixturing in order to make the product work. They are typically working under the microscope about 80% of their day. Hand-eye coordination and manual dexterity is critical. Dexterity is a must, accuracy is a must, and attention to detail is a must.
Boy, I see Transonic in the future in a lot of different places. I'm hoping that we can kind of move into new applications and new areas for hemodialysis and new applications and areas for our OEM clients. I think there's just a world worth of measurement that hasn't been done yet that we would like to be a part of.
The most exciting part for all of us is watching our technology in action, both in our own products and especially in our OEM customers' medical devices. Accurate flow measurements can make a huge difference for our customers and their patients. Transonic's mission is to advance meaningful measurements. It's in our DNA to deliver ever better flow measurements to our customers to optimize their products and their applications.
I am immensely proud of our team at Transonic and our collaborators worldwide that we pioneered transit time ultrasound technology and use it to improve the fields of healthcare and life sciences.
Each year, thousands of patients die from unseen issues that cause premature graft complications. Hospitals and healthcare systems risk millions in revenue loss, reputation damage, and low patient satisfaction for avoidable reinterventions. Intraoperative volume flow measurements expose the often hidden sources of anastomotic failures, significantly increasing vessel patency and reducing the cost of care. Transonic's new FlowXL provides accurate and easy-to-use flow measurements, leading to improved outcomes, patient safety, and peace of mind for the surgeon. The FlowXL full-color capacitive touchscreen can be table-mounted, pole-mounted, or set up as a fully integrated flow system. When fully integrated, the flow system is comprised of a transport cart with a 21-inch monitor that rotates 360 degrees. Easily observed from a distance, the extra display allows a surgeon an unobstructed view of flow values and waveforms. Despite the large dual monitors, the fully integrated system's footprint is a compact 20 by 20 inch. FlowXL software is simple to use, highly configurable, and can be customized to your preferences. Standard features include 2 flow channels and pressure or ECG for colorized waveform analysis. Quick Flow Mode offers plug-and-play operation for the easiest flow measurement experience. Advanced Flow Mode enables patient data capture and management capabilities, including annotation, report generation, and printing. Transonic's proprietary flow sound assists the surgeon by communicating flow values audibly. A surgeon can save precious minutes in confirming functionality without ever taking their eyes from the surgical field. Transonic offers the widest variety of application-specific flow probes to complement the FlowXL. Whether measuring lymphatic fluid in vessels as tiny as 0.5 millimeters or high-volume aortic output, Transonic provides the probes you need to confirm your anastomotic success. You can't manage what you don't measure. Excel at your flows with the Transonic FlowXL.
Hello, my name is Sierra Coyle. I'm a respiratory therapist and the ECMO specialist at Transonic. In this video, I will be discussing recirculation in VV ECMO patients, why it's important to quantify it, and how to improve your patient's therapy. Recirculation, a known complication of VV ECMO, occurs when the drainage cannula absorbs a portion of oxygenated blood from the reinfusion cannula. Long-lasting periods of recirculation reduces the delivery of oxygen from the ECMO circuit to the patient. Without optimal therapy, an ECMO patient will quickly decompensate. Historically, recirculation surveillance has relied on subjective measurement, making it difficult to detect and quantify. The most obvious indication is a low arterial oxygen saturation with a high pre-oxygenator saturation. Other subjective clinical data potentially include low PaO2s, increased ventilator settings, change in vasoactive support, and suboptimal cerebral saturations using NIRS monitoring. Regardless of these signs, medical teams still struggle to identify how much recirculation is occurring and how seriously it is affecting the patient. Early detection can lead to faster improvement and successful weaning from ECMO. ELSA, the extracorporeal life support assurance monitor from Transonic, not only confirms recirculation, but also gives an actual percentage of recirculation. Measurements are obtained with a simple isotonic saline bolus. Quantifying recirculation provides the actual oxygenated ECMO flow being delivered to the patient. This allows the clinical team to identify the loss of oxygen delivery to their patients, ultimately determining the quality of the ECMO therapy. Once recirculation is identified using the ELSA monitor, steps can be taken to eliminate and reduce recirculation and optimize treatment. For all VV ECMO configurations, cannulas must be placed in the ideal position within the venous circulation. Take note how each cannulation technique is susceptible to recirculation. Bifemoral cannulations use both femoral veins to obtain ECMO support. Proximity of these cannulas to each other increases the chances for recirculation. Femorojugular cannulations utilize a patient's femoral and right internal jugular vein to provide support. The tip of each cannula faces each other, creating high rates of recirculation if positioning is not perfected. Double lumen cannulas operate with 3 ports, 2 for draining blood into the ECMO system, and 1 for reinfusing oxygenated blood into the patient. While the basis of this configuration is ideal, a poorly positioned DLB can result in turbulent flow, high recirculation rates, and poor drainage properties. Fortunately, specialists can perform a recirculation measurement using the ELSA monitor during cannulation to help surgeons locate ideal placement. High ECMO RPMs increase the likelihood of recirculation. Any VV ECMO flow exceeding the patient's cardiac output causes recirculation. For example, the patient's cardiac output is 3 liters a minute, but the ECMO flow is set for 5 liters a minute. The difference of 2 liters will be recirculated. This does not improve oxygen delivery because the effective ECMO flow the patient receives does not increase. It is important to identify optimal RPMs to provide the most effective ECMO flow possible. High RPMs can increase hemolysis, which can lead to serious complications. When VV ECMO patients are hypovolemic, inadequate preload will increase recirculation. Providing a fluid bolus or adjusting diuretic management should help correct the lack of forward flow through the patient's native outflow tract. A recirculation measurement can be taken before and after the fluid bolus to quantify improvement and guide effective patient management. If the previous steps have not improved recirculation, then the patient's cardiac function may be the cause. Evolving heart failure decreases the heart's ability to pump effectively, reducing the overall cardiac output. As cardiac output decreases, recirculation will increase. Recirculation measurements may help indicate heart failure that can then be further assessed by an echocardiogram. Recirculation has long been known to be an undesirable component of VV ECMO, but has previously been hard to quantify. Transonic's ELSA monitor is a powerful assessment tool that allows for early quantitative detection of recirculation, which can be caused by cannula misplacement, incorrect pump settings, hypovolemia, and cardiac failure. Now, for the first time, clinicians can obtain quantitative recirculation percentages, which they can use to improve their patients' VV ECMO therapy.